record for me, otherwise, when I'm alone, again, when I listen what you are explaining, I get a lot of sense.
All
But
right.
now it's like I'm bringing the ear closer to the phone. Again, I want to see also what you are doing.
Okay, don't worry. You'll be able to catch up. Don't worry.
All right.
Sure thing. So,
Use 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 every simple word so that I get something.
all right, all right.
Mm.
Okay. So we are talking about motion in one dimension. When something is moving like this, it means it's moving whether up or down or horizontal. So it's going there or like this. So it's moving like this. Okay, this is motion in two dimension. All right. So now that's not our area of interest. I was just trying to demonstrate how we can actually see that this motion is in one dimension, this motion is in two dimension. So here, when something, let's say, is thrown up like that, a board is thrown up, so it does the motion in one dimension because it's only concentrated in the y-axis, not in the x-axis. So it's only in the y-axis. So that's what we call motion in one dimension. We just look at one. All right. Example: a bus moving from Lusaka to Kabwe. Let's say Kabwe is there. Okay. Then Lusaka is there. So if a bus is to move like that, to Kabwe, it
Ahead.
if like I'm just trying to understand like the meaning of motion. If something is to move, let's say from Lusaka to Kabwe, that is the motion in short.
Yes.
Okay.
Yes.
Then if something is not moving, like a car is not moving, this means that a car is at rest. At rest, these are the terms that we need to find to understand.
At least die.
At rest, yes, it is at rest.
Mm.
Okay, so this one is in motion because it's moving. Okay, is that clear?
Uh, yeah.
So first term I've stated is motion. Let's go to another term. So the other term that I need to give you is um okay, the other term that we need to understand is what we call position.
The what?
Position.
Or position. Okay.
Yes, yes, yes. So when you say position, position tells us where the object is.
The what?
Position of something is where it is. Like something is where it is.
Yes. Yes.
All right. So at this point, a starting point is what we call the origin. Okay, let's say start from here. This is what we call the origin. Original point, we call it origin, the starting point. Then if it is to move like that, this direction is taking, it can be negative or positive. So it can move this side or it can move this side of the axis. So here, if it's moving this side is positive, if it's moving this side is negative. So these are the motion. So the position can be at the origin, or it can go this side, or it can go this side. So if it goes to your left, it means it is entering the negative side of x-axis or of the axis. If it's going like this, it means it's dealing with positive axis.
Okay.
Yes. So this means that if you are to stand at Eden Gate, like Eden Gate, this is the Eden University, then the gate, this gate, okay, this gate, if you are to stand here, okay, this is your position, okay.
Yes.
This is your position. So at the gate here, if I'm to get at the gate here, you are at the position. So even counting is 0 meters if we are to count your distance that you want to travel to reach the final destination. Suppose these are the classes there, yes. Then you are to move like that, you enter inside, you go to your class like that. So that is now, let's say the class it is as it position 20 meters, okay? Okay, so and also that is 20. You going straight is 20, but again you coming back like that opposite, so that would be let's say you are, yes, negative, let's say 20. All right, so that is the position meaning. All right, so in short, position is just the origin of something. That's what I want you to understand.
All right.
Yes. So the next thing that we are going to talk about is what we call displacement.
Sorry?
Displacement.
Or displacement.
Yes. Okay, when you say displacement, it's just a change in position, okay? Suppose you are standing here and Sianyolo is here. So you have to pass through Majejete here, okay? So this is Ichanga, this is Sianyolo, where you are now supposed to go. Then this is Majejete. All right. So you are supposed to go to Sianyolo to use this direction, right? But now
Use which one?
this is Changa. This is Sianyolo.
Okay.
This is Imajejete. Alright, so you are supposed to use this direction from Changa to Sianyolo like that. Okay, I mean not like that. You are supposed to pass through Majejete like this, then Sianyolo, right?
Yes.
Yes, but the displacement, it will be the distance that it just point at exact position. So you measure your displacement will be this point because you are just going straight. There's nothing like making a turn like that. So that's what you call your displacement there.
Oh.
Yes, but the distance, it will be that one when you use this one. The distance that will cover to this point is what you call the distance. But the displacement is that shortcut which point just at exact point. You get me?
Displacement.
Displacement, you are just displacing something straight.
Okay.
So this is distance, like if you are to cover from Majejete, but if you have a like a point from let's say Sukwasabion, we are to using like the route, let's say okay, you are going to Chimata, you do a shortcut there than using Sianyolo. That will be your displacement.
Okay.
Yes, so I want you to understand that if I have a point like this, then I move to the, let's say this is Chirundu, then this is Changa, then this is Chirundu. So the distance is what you have covered like that, long like that. But the displacement is just concentrating on what is straight to that point. So this is the displacement.
Okay.
Yes. So if you are to move, let's say you are here, then you move to, let's say, Gupira, okay? Is that okay? So displacement moves like this. So you are moving here to Gupira there. So if you move and you come back again, you stand here, it means your displacement is 0 because we have looked at you have moved nothing, you have come back to your initial point.
Okay. So
Yes.
the displacement 0.
Yes, it's 0 because you have not displaced anything. You have gone there and you have come back there.
Okay.
Yes, we are looking at where you have ended and also from the initial point. So you started at this point and again you ended at the same point. So your displacement is 0. But suppose this was 2 meters. Okay? Because you have moved positive 2 meters, then you have come again negative 2 meters. Is that okay?
It is 0 now.
Yes, that's your displacement because we are looking just at that final position, at your origin. Yes, so the other thing that I want you to understand is that the distance now, it will be just the total distance like you have traveled. Okay, so that will be probably 4 meters. That is your distance.
Yeah.
You have seen now the difference between displacement and distance.
Yes, I've seen the difference now.
Yes, so what we do is displacement will be gotten by saying final position minus initial position. Is that okay? Yes, so if
It's okay.
yes, if you were at this point, let's say it's 0 meters, then you are to move to something like 20 meters. Or let me say this is 10 meters, then you are to move to 20 meters. So your displacement, it will be just see what is the difference. So you say 20 minus 10, which is what is the answer?
10.
So this will be your
So that is
displacement.
10.
No, it's just 10, like just 10.
So just 10.
Yes, yes. Final
You say,
minus initial.
okay, but just a minute. You said you just moved 10 instead of 20.
So
You do minus, right?
like we look at where, so we said it's a final position minus initial. Initial is simply means your origin, like that position, your origin position, where you started from. Yes, so you look at the difference. We are just looking at the difference. That's why here you found that to find displacement, we found the difference, and the difference between 2 plus 2 minus 2 is 0. That's why we found that displacement here was equal to 0. Because we moved from 2 and again coming back, we deleted that 2 we had made.
Okay.
Sure, so this will be meters like that. It's measured in meters. This is just the opposite of the distance.
Okay.
Alright, so the other thing that we can talk of, example, let me give you example. Again, let me just give you another example to clarify, to solidify. So suppose you move from 0 meters to 30 meters. Okay, so your displacement there will be final minus initial. Initial, it means where you have started. Okay,
Sorry?
initial. The word initial simply means at the starting. Initial.
Starting point.
Yes, origin. Yes. Okay, so now you say we ended, our final was 30 minus, we started at what?
0.
0 meters. Good. So that will be 30 meters. So that will be your displacement. Equally, in this point, in this case, the distance will be equal to the displacement. Aye.
Sorry?
In this point, the displacement is same as the distance because they are just in one point. There's nothing like making a curve, coming back.
Okay.
Yes, you find that this distance, this displacement, it has a direction, like we could consider the direction, let's say from here to there. So this means that displacement is a vector quantity. I will explain this in the when you say a vector and yes, a vector and scalar. I will explain this later, not now. I know I'll meet a question somewhere. So a vector is just something that has a magnitude and a direction. Okay, so the direction that we are talking about is what we are considering here, from Sianyoro to Changa to Sianyoro. That's a direction. Okay, yes, you just point out the direction.
So a vector is something with direction and displacement, eh?
A vector, so let me do this. A vector will have a vector quantity will have a displacement and magnitude. I mean, let me say a vector quantity will have magnitude. Magnitude is just a value like 30. Okay?
Sorry?
Magnitude, when you say magnitude, we mean the value of something. Like in this case is 30, that's a magnitude.
Okay.
Then a direction is like the way we pointed at 20 north, 20 east. You get? When I mention something like east, north, that's a direction. So it has a direction. Okay?
Okay.
So a vector quantity is a quantity that has both magnitude and direction. So I think maybe that one you can master it. Then there's also what we call a scalar quantity. A scalar quantity has only magnitude. It doesn't have a direction. This one has direction. This one has a direction. Both the direction and magnitude. Here is only magnitude. We don't consider the direction. Like distance, you only look at the distance. Let's say 20 meter traveled. You won't say 20 meter east, 20 meters north. You get? Like at this point we're in Changa, you said I'm going to Sianyoro. It is, let's say, north of you. So you say 20 meters north. 20 meters north. Not you say 20 meters again in Shan. So in short, you look at the direction when you talk about vector quantities. So it has direction, or everything, like anything that falls under vector is that it has both magnitude and direction. Magnitude and direction. Alright. So now let me classify on the differences between distance and displacement. Okay? Differences.
Between
displacement and distance.
Okay.
I want you to differentiate. Are you writing somewhere?
Sorry?
Are you writing somewhere?
No, I'm just following. Theoretically, the goal is, if possible, I should finish the important thing in that car, but they are not that much a lot. But we have to understand a lot of things. If you are recording, then the day I'm going to like writing and I see what you are recording, and I'll go also like writing also somewhere.
Alright, I get it, but alright. Okay, but it has reduced a bit there, right? The lane has reduced, right?
The what?
The lane has reduced a bit, right?
Yeah, at least
okay, so the difference is, one, when you talk about the distance, we are talking about the total path. Okay, total path traveled by an object. Is that okay?
Yeah.
So, but when you talk about distance, displacement, we are talking about straight change in position. So, like I explained, like you just look at straight.
Okay.
Yes, straight change in position. So this is what I'm trying to say. Like you have a point there, you are moving like that, then you move like that. Your origin is here and your destination is here. So displacement, it will talk about straight change in position. So this change that will take place between here, that is your displacement.
Okay.
Yes, but this change that will be like that, total path traveled is what we call a distance.
Now.
You get now?
Yes.
All right. So suppose you're from moving like from your BH or your hostel. Let's say you have like this is your hostel, right? Okay, this is your hostel. Then you move from your hostel to class. Let's say 50 meters. Then you return. You return, let's say 20 meters. Okay. You get me?
Where are you right now?
So you return 20 meters. So this means that your distance now, your distance, it will be what you have covered, which is 70. Everything. Is that okay?
Yeah.
But this is the distance. But the displacement, let me use the small letter. The displacement, it will be, you subtract, you just look at the change path in path. So if we are to, you say 50 minus, because we came back again. Once you are coming back, you are deleting what you have covered.
Okay.
Yes, it's more like you are at this point, you have gone there. Your foot symbols, once you come back, you are deleting them because you are stepping twice on those. That's what you call displacement.
Okay.
So that will be 50, what you had covered, minus again because you have come back, so that will be 30. Clear?
Very clear.
Okay, so this you need to know that
I wish you were the one taking the class.
don't worry, you should invite your friends if possible. Okay, so this means that, yes,
I'll invite Edge. I can start also donating. I'll invite them.
yeah, if you want
I don't know how to.
that,
I don't know how to invite.
like you just paste, copy that link, then you paste in the group. That one I pasted, then you post it to say why join. They tap on that, then they will join. Like that link I've shared, you can just send to a friend, then a friend is tell them to say open this, there's a meeting you learn, and they will join. Yeah, that's how it goes.
Alright.
Okay, we continue.
Yes.
Alright, so you need to know that distance is always positive. Is that okay?
It's always what?
Positive. You can't report a distance that I've covered negative 3 meters. No. So it can't be negative.
Okay.
Sure. So that is it. Okay. Like, do you have friends?
Sorry?
Do you have friends?
I found it. I think it's two. 2 to 3 friends, I think.
Of your case who are in the same case, like upgrading.
Yes, yes, there are about 4.
You should do invite them.
Okay, I'll invite them. I only have one number for one person.
All right, all right. Okay, so
Or
so,
two. I have 2 numbers.
so you are sending or we just continue?
Sorry,
We continue or you are sending it?
I send now.
I don't know if you are sending or I continue. It's up to you to choose.
Uh, okay, let me send.
So what you do is you copy that link, then you just paste it in the inbox.
Okay, let me copy it. Then I send. I see if they are still alive. They haven't slept.
Okay, okay. Is there someone who's awake?
Last 15, 10, 31. Maybe this one will see.
Yeah, what 10:31 to be on?
Let me look for another one. I have 22. So I'm going to see another one.
Okay.
Okay, the last one, I think this one. This one is in a long time. 1919.
But
These people are sleeping.
this one, like your face, has it marked like twice?
Okay,
Has it marked it twice, that one?
this one, the other one,
Hmm.
that's Longo, I think. Or Yulango. This one might join this one.
Yeah, you tell them to say, join your learning physics.
Oh, alright. Lucky join.
Chonka, it has marked bro.
Sorry, okay.
Okay, he has joined. Oh, Alright, so now the other thing that we are looking at, So help me to mute your mic. We are looking at now velocity. We talk about velocity now in detail since we have looked at displacement, everything like that. So Mr. Christopher, you are welcome. Like you have just started, we want to summarize this motion in one dimension. The lecture note that you were just sent, we are trying to simplify and so that you can understand them properly. Okay.
Alright. Yes.
So yes, so when we say velocity, we mean the rate of change in position. At what rate? When you say rate, meaning that time is involved. So when you say velocity is just the rate of change in position. That's what we call velocity. All right. Is that okay?
Yes.
All right.
Christopher still there.
All right. So that's what we mean. So there will be a change, and we said change in position is what we call displacement. You remember? So meaning that velocity, okay, meaning that it will be given as displacement, change in displacement. All right, change in displacement over time. Because of the word late there, we mean time. Okay, so this means that velocity is equal to displacement, all right, then over time. So this is always displacement. This is change in position. We defined displacement distance. So they are by I think you can, when I'm talking there, you can switch off your mic. You can mute your mic, please, so that you're able just to get me alone. Yes, you mute. Thank you. So when you want to ask, that's when you say, you open your mic, then you proceed. Okay. So for now, I'll be just talking. So distance, this is displacement and not distance. Distance and displacement, they will be equal if they are in one path like that and there is no change. Okay. So if you are traveling from here to your campus, okay, let's say this is campus. So when you travel like that to reach that point, what you have covered is what we call your distance, and this distance again, it will be equal to displacement. So it is at this point, but if you try to come back a bit, meaning that you are reaching your displacement. Okay, so example, like a car, let's say a car travels 100 meters, okay, in, let's say, 10 seconds. Okay, in 10 seconds, find the velocity. So velocity to be given as the distance, which is whatever is, if it's the distance or displacement, but should be the same if they are in one direction. So what we are trying to say is we have the distance like we stated, which is 100 meters, over the time. The time is 10 seconds. Always time should be measured in seconds, and these units, you will see how they will give us the answer. So if I'm to divide, that is 0 and this is 0, will remain with 10. We have meters on top, then down there we say per second. Is that okay?
Yes.
So we can say now velocity is a vector quantity. Okay, because has a what? A direction. Why direction? Because it's coming from displacement, which has a direction. You remember? It's a vector quantity. Okay, good. Alright, it's a vector quantity. Why? It's coming from a displacement, which is a vector quantity. For time, we don't even specify it's a vector or what. So that to proceed. So let me actually take you through. Is there a question before?
No, I can forge ahead. Maybe Christopher.
Mr. Christopher, is there a question about before I start something?
No.
Sorry?
No, sir.
Alright.
Just continue. No.
Okay, so the other thing now, we are going now into details. We're talking about now average velocity. So we need to understand all these, and we'll be able to solve different questions if at all we're given questions. So we'll be able to solve together different questions next time. But for now, let us understand these terminologies and what is happening, what are they about here. Okay, so average, we mean something that is just a variable. Is that okay?
You're saying?
Average, we are talking about average velocity. So we mean something just that is a variable just to its maximum. We call it average. Okay? So something to its maximum is what we call, I mean, like something that is a variable to its maximum, we call it average. So by this average velocity, I'll call it to say we need to get the total, okay? Total displacement over total time. Is that okay? That's why I said when you hear word average, look at what is just a variable. Okay, this is what you call average velocity. Remember, just velocity could be given as displacement over time. So this is what we could see from just talking about average velocity. So we get the total time and also the total displacement. Is that okay?
Yes.
Example. So Mr. Christopher, this one is being recorded. You still watch it on YouTube. Is that okay? So make sure that you just get the partial information, then you still get clarified on as a video. So from there, what we do is we are saying suppose now you have like a student, let's say, walks 200 meters. All right, a student walks 200 meters east. You know, the moment I list this word east, just know that that's displacement. I said displacement is a vector. It has direction and magnitude. The magnitude that I have is this, then direction is east, right? We get directions north, east, south, right? Okay, so a student travel 200 meters east, okay, in 50 seconds. So find his average velocity. So what is a variable? So average velocity is just same as velocity. So where we say the displacement, which actually gave us a clue by virtue of us seeing east, which is the direction. So that's our displacement. So our displacement, we know average velocity is equals to displacement over time. Time a variable. Total. And you say total there and also total time there. Okay, so total displacement is 200 that they have given us, 200 meters. Then the time given is 50 seconds. All right, so this means that this means that 50 there can go and also 50 there, I mean 0 there can go. What is 5 into 20? Means that we have 4 meters per second. 4 meters per, because the S was down, then east. You don't forget this because that's what the direction which was there. So this velocity is also a vector because it has a direction which is east and also the magnitude which is 4. Okay. Okay, so again let me just allow them. Mr. Clement. Alright, Mr. Clement, you are welcome. Okay. Sure. So that is it. So that is about to average velocity, and we have got the velocity itself. We have now classified what is average velocity, but what is a variable, and also the displacement are variable, and also the time are variable. Is there any question before I go to the next thing? So Mr. Clement, don't worry, you still find the you catch up. Just try to follow, and you will give you a video like you watch it on YouTube. Is there a question there?
For me, no.
All right, that's good then. So let's talk about now 7. So I picked all the points in your lecture notes, and I'm here to give a clarity. So the other thing that we need to talk about is the speed. All right, so when you say speed, we talk about the distance over time of something. Okay, that's what we call a speed, distance covered over time. So speed is opposite of velocity. Okay, there was velocity uses displacement on top there, so say velocity is equals to displacement over time. Okay, this is displacement, this is distance, this is displacement. So this is how they differ. This is the distance, this is displacement. Is that clear?
Yes.
Okay, so when I'm interested in talking about average speed. So speed is just, when talk about speed, is the distance traveled per unit time or per given time. That's what we call speed. So speed, I'm talking about average speed now today, because that's what was there in your lecture note. So average speed. Okay, so when you talk about average speed, is actually, when I say average, remember for average velocity we could talk about total. So average speed is equal to total distance. Total distance are variable. Okay, so say total distance, okay, over total time. Is that okay? Please, when they include this word average, just talk about everything like in total you are bringing formula. Just we stated for speed we could get this, but now it's talking about the total to be the average. If you are talking about average, you're talking about what is a variable. That's average. So what is a variable, what has been made, is we'll take it as total to actually embed whatever everything we have. We call it average. Like, what is a variable, then we total it. That's average speed, that's average velocity. You get? So that is it. That's how we could even get the average velocity to say the total displacement, if you remember on the previous page, and also the total time. That's what we call average. So at this point, you talk about now these two having just, the other one uses displacement, the other one uses distance. That's what I differentiate these two. They normally ask twisty questions on that, on this. Is there any question, like, or it's clear before I give an example? Sorry?
And let the others also switch the mic when you are there's a feedback.
Alright, so please there, if you are okay, let me just check out the lesson, like to switch just off the mic, like okay. Also, you open it once you, yes, good.